the most important in CCNA. IP addresses. When you know IP address, anything else is much easier, I'm telling you. So we started a bit with the definition of IP address. It's like your ID number or your passport to identify you. We cannot get two IP addresses for the same device, never. We also checked that we have three classes of IP address, class A, B, and C. And you know how to identify them. We did an example of each of them. For example, if the first block is between 0 and 126, it's class A and so forth. The same thing for this one. What are the two ways a device could get an IP address? And we say that we have static, and you can manually add, or the device can get automatically via a device called a DHCP server. A DHCP server. So all this stuff we did. So at a later stage, we're going to do revision. We're going to do revision on all of them. So today we're going to do something extremely important. Extremely important. So let's check together. What is that? Very important. It's called subnet mask. And I'm going to show you now. One second. Someone want to log in to connect. One second. Okay, so something very important called subnet mask. So when you have an IP address, it doesn't come alone. It comes with another number called subnet mask. So subnet mask is a number to identify you belong to which network. So we took an example of a room. You have a big house, and you want to divide in smaller rooms and rent to people. So if Tanya comes, Tanya will show you her ID, but we need another number to identify in which small room or in which room you belong to. So you have your ID, Tanya ID, and another number to identify the room number. So that when Tanya comes, you belong to room 1. James will come, you belong to room 2. So anytime you have an IP address, we have a subnet mask. So a subnet mask is used to determine the network in which the device belongs to. Let me ask a question here. What's the definition of subnet mask? So all of the questions we ask a lot for job interviews, exam, and for your own IT knowledge. So please study well, take it seriously. Now, let us do an example. It's very simple. So we have something called default subnet mask per class. It means if you have a big room and you don't divide, there is a number for that. There is a number. So let's say for class A, when you have class A, so an IP address has 4 blocks or 4 octaves. First block, like this one you see, 192, that will identify in which class you belong to, then dot another number, dot another number, dot another number. So the maximum should be 255. Maximum should be 255. So all these numbers should be maximum is 255. It cannot be more than 255. We're going to explain shortly. So it has 4 blocks now. So class A, the first block will never change because the first block will identify the network. And the other 3 blocks will represent the host. You see that's why it's HH. Then the network part, we replace all of them by all ones. And did we do conversions? Not yet. Okay, I'm going to show you shortly. And we replace the first block by all ones. And the host will stay because the first block will represent the network. So we replace all of them by 8 ones. That's why we say /8, because we have 8 ones. We're going to do a conversion shortly. If you convert binary in decimal, it will be this value. We're going subnet mask for class A is /8. If it changes to /9, 10, or 11, it means I divided my big room, my big house in smaller room. So the default is /8 or 255.0.0. I'm going to explain more shortly. For class B, the first 2 octets or the first 2 blocks never change. It will represent the network. That's why it's NN. And the other 2 blocks will represent the host. So because the 2 blocks are NN, we're going to replace all of them by 1s. So 8 ones plus 8 ones, we say /16. So if we say /16, it means we have 16 ones. And when you convert each block in decimal, we have this value. We're going to do some example of conversion shortly. Then for classes C, the 3 first blocks will never change. It will represent the network. So because of that, we change all of them in 1s, 1, 8, 8, 8. And the last block will be representing the host. We leave it. So because 8 plus 8 plus 8 is 24, 8. If you count always 8, that's why we say /28. Sorry, /24. 8 plus 8, 16, plus 8, 24. That's why this 24 is here. So when you have an IP address and in the class B, the default subnet mask is /16 or 255.255. If it changes to /17 or 18 or 20, it means something has changed. My big house, only one has been divided in smaller rooms. At a later stage, we need to identify how many smaller rooms I have, and per smaller room, what is the first host I can assign to a PC, the last host I can assign in a broadcast, and we are done for chapter 11. So the very most important, it is what we're going to do today. So for conversion, we didn't do conversion yet, so I'll send you there. We're going to do a bit of conversion, then we continue. I think conversion was, conversion was chapter 5, but we'll do that. So during the weekend, I'll give you some homeworks to do based on what we're going to do today. So it's very important. It's not difficult. We're going to do it many times. Even next week, Tuesday, I'll do the answer to your homework. Then we continue. So next week, what is that thing? So next week, Tuesday the 3rd, we're going to work again on conversion. Let's say, yeah. So today I'm going to combine, if you want, chapter 5 and chapter 11. So during the weekend, I'll give you homework based on chapter 5, something simple, I'll show you now, and chapter 11. Then on next week, the 3rd, Tuesday the 3rd, next week, Tuesday the 3rd, we'll do the answer of your homework. Please do them, it will help you if you have questions and all this stuff. Thursday, we'll continue with something else, maybe chapter 4, chapter 3, something like that. Then Saturday, the 7th, we meet in person at the Cape Town Science Center to do a big revisions of everything and also configurations. We're going to use again the equipment. This time, we're going to configure routers. We're going to configure routers. For those who missed the first session, we'll do revision for you. So students who are there, we're going to assist you how to connect your laptop to a switch by using a console cable. We'll do revision on that. See console port. That's why you must download the link. I'm going to send you, forward you again the link. You must download Teratem and also the driver for the console cable. So we'll do that again later. So Saturday, please don't miss. We're going to work a lot. Revision how to log on a switch and do basic configurations. And also, we'll do the same thing for the router. So please eat well before you come. Bring some snacks or some drinks because we're going to work from 9 a.m. to 4 p.m. So next week, Thursday, before we meet in person, we'll do. So today I'm going to combine chapter 5 and chapter 4, 11. It's very simple, not difficult. Then next week, Thursday and Tuesday, we do the answer to your homeworks. And Thursday, we do basic routing configurations. These are the two most important for the very first part of your CCNA. So CCNA, remember we have part 1, CCNA1, part 2, CCNA2, part 3, CCNA3. So normally this week, I can say that we covered 80%, 80% of that's why I want to push. After that, I'll give you a big project. While you'll be busy on your project for 2 weeks, I'll be helping the IT Essentials guys who are starting the CCNA with us. While you're you're busy, I'll help you for 2 weeks. After 2 weeks, we all join again together and we continue. So you're in good hands. So yeah, next meeting will be doing switch and router. Let's do a bit of conversions. Conversion. So in the world, for us human beings, we have many types of counting. Since grade 1, we know decimal numbers for human beings. And for human beings, we know 0, 1, 2, 3, 4, 5, 6, what we know. Then the PCs, the machines, they don't understand all these things. They understand 0 or 1. We call it a bit, the bit 0 or the bit 1. So because it's 0 and 1 only 2 numbers we understand, we say binary. We say binary, we understand the binary system, 0 and 1. Then we have another counting system or number system called hexadecimal. This one is mostly for MAC address. So for hexadecimal, it's that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. From 9, it stopped, and it continued with A, B, C, D, E, F. So this one is mostly for MAC address. MAC addresses. For MAC addresses, this one I can say for human beings, and this one for PCs or machines in IT. So number system, what is it? So question number, okay, we're going to do that, but here for your questions. All right. Right. 3 number systems. Okay, yeah, that's right. 3 number systems. So these 3 are what? Decimal, binary, and hexadecimal. So this one is chapter 5. It's something simple we do together. So now how to manipulate, how to change, to move from decimal to binary, from binary to decimal, and hexadecimal, all of this stuff. So here you have an example, decimal. Let's say you have decimal 98 and you want to convert in binary. To do that, you need a table. This is your table, your friend. From now on, you have a friend called this table. It starts with 128. You divide by 2, 64. You divide by 2, 38. After that, you divide by 2, 16 until you reach 1. This is your table. Now, if he asks you 98, what is the value in binary? What you do is you put 98 here, equal. The most difficult part in CCNA training is this one. After this one, it's finished. Anything is easy. Because this one is grade 1. If you pass grade 1, it's finished. Grade 2, grade 3. It's not difficult because it's the first time, and that's why we're going to do a lot of time, especially next week, Thursday. So when you have 98, 98 should be a combination of which of these numbers? So I can see that 98 is bigger than 64. So I can say 64 here, minus. So if I take my calculator, I put it here, and we say in 98, I can deduct 64, right? And the balance is 34. Now I see that 34 is bigger than 32. So I put here 64 plus 32. Then that 34, the balance, I can deduct 32. 32 is too big. Let me put smaller. So in that 34, I can deduct 32. The balance will be 2. I don't know how you call it, the balance. So will be 2. It means the balance will be 2. And in that balance of 2, I can deduct 2. I can deduct 2. And we are done. So now you take your calculator to make sure that 98 is 64 plus 32 plus 2. Let's check together. I clear everything. So I'm going to check if this one is equal to 98. So we go there. I take 64. 64 plus 32 plus 2. We can see that it's 98. So for now, it's correct. Everything's correct. Now, because I took 64, I'm going to put 1 under. 1. 1 times 64 is 64. I took 32. I'm going to put 1 under. And I took 2. So I didn't take 16. There is no 16 here. So it will be 0. Because I didn't take 8. So it's 0. I didn't take 4. It's 0. Did I take 2? Yes. Then it will be 1 here. Did I take 1 here? No. Then it's 0. See? Did I take 128? There is no 128 here, so it's 0. So you see? Then this is your answer. The value of decimal 98 is, you see, all these numbers. You start from right to left. So 0, 1, 1, 0, 0, 0. So you see. So 0, we start from right to 10 to left. See, this is the value in binary. Remember, this training is international. It will be same system, same content, same certificate anywhere in the world. So an American guy who has CCNA is the same like you, same content, same certificate, same exams. So that's it. So normally, if you know this, I can say you are. So we're going to do another example. And this one, you must do it yourself. You must convert, let's say 122 decimal, convert decimal, let's say decimal 150 in binary. Oh, sorry, here. In binary. Okay, I give you 5 minutes to do that. Then I'll do the answer. Then you tell me who got it right. So do it for 5 minutes. Are you done? So I'm going to do the answer. I'm going to give you answer. So how to do that? You type 150 equal So in that 150, I need to combine to find the combination of this one in. And you start 150 is bigger than 128. So I can put 128 here. You see. Then you take your calculator, you clear everything. 150 minus 128 and is, you see, 22. Now 22 is bigger than what? 22 is bigger than 16. Then I can take 16 here. Then you take your 22 minus 16 that you took. Now you have 6. 6 is bigger than 4. And then you take 4 here. Oh, sorry. 4 here. Then in that 6 minus 4 equals 2. Now 2 is bigger or equal to 2. So it's fine. Then you keep the 2 here. And because I took 2 minus 2, I'm going to have 0, which means I'm done. See, I'm done. Then you take your calculator to make sure that this one is equal to 150. Then we're going to do it. To do that, I clear everything. So I'm going to check if this one is 150. So I put 128 plus 16 plus 4 plus 2 is equal 150. See? So this one is equal to 150, right? Then I remove everything here. Okay, now did I take 128? Yes, it's here. You put 1 under. I go to 64. Did I take 64 here? No, so I put 0. Did I take 32? 32 is not here, so it's 0. Did I take 16? I check here. Yes, 16 is in. Then I put 1 under. Did I take 8? There is no 8 here, so it's 0. I put 0 under. Did I take 4? Yes, I have 4 here. I put 1 under. Did I take 2? Yes, I have 2 here. I put 1 under. Did I take 1? There is no 1 here, so I put 0. And this is the answer. And your answer is the value of decimal 150 is, then you take this number now, you put from right to left. So you see 0111, 0110 is here, 0110, you continue it here in binary. So I'll give, oh, sorry, it's not there. So I'll give you some examples to be done during the weekend.
Sorry, Mr. Max.
Your name and your question?
Yes, Fabian is my name. I just want to ask,
Okay.
For the two examples here, you're still referring to the decimal 128. My question is, why are you referring to 128 in everything you do? You started with the 128, even though you put a new example of the 150, but we know 150 is bigger than 128. Yes, but what you're referring on 128, is it a standard numbers that we need to refer to, or maybe something else that I don't understand?
Okay, so this table is a rule. Is a kind of rule. I'm going to put it here for you. So normally when you count in base 2, you have a position. I didn't want to tell you, but because you asked a question, I'll tell you. You have a position, you have the base, and you have a value. Position 7, 6, 5, 4, 2, 1 and 0. I think we have position 8. Huh? I'll check for you. Position 8. Base, because you're using base 2, we count in 2 for binary. We base into base 2, that's why I say binary. It's either 0 or 1. So I have two choices. That's why I say 2, base 2. Put 1 there. Base 2. Now the value, we start with this one, 2 to the power of 0. When you take your calculator and we go to scientific. So it's a ruler. So I want to show you where it comes from. 2 to the power of 0 is 1. And put that 1 here, value is 1. Now, that's why I say position. Position 0, the first position, not position, sorry, I meant it's 3. Here there is 4 meanings remaining. Position 4. I think this one doesn't exist. Okay, let's leave it for now and check it again. Okay. So 2 to the power. Who's logging now? I must log on early. So 2 to the power of 0 is 1. 2 to the power of 1 will be 2. If I take here, I clear. 2 to the power of 1 is 2. Oh, okay, then let me start from here then. 2 to the power of 8, let's check. I clear. 2 to the power of 8. Yeah, that's why I say this one is not in. We start 7. Yeah. 2 to the power of 7. Let's check. 2 to the power of 7. Yeah, this is where your 128 start. The value 128. Then 2 to the power 2 to the power of 6. 2 to the power of 6, it's 64. And you continue. If you do that, you'll see 32. If you do that, you'll see 16. You do that, you'll see 8. You'll see 4. You'll see 2. And you'll see 1. So that's why when you want to do the conversions, we take that table. So this is where it starts. So if you go in chapter 5, it's explained in AutoCAD also the same thing. So I wanted to make it very simple, short, but okay. Anyway, that's why we focus on this table here. So, yes, question?
Good evening, class. My name is Sharon. So, sir, I also have a question concerning that value.
Yes.
Are we always given it, or do we have to create our own, or is it always
No. No, always you yourself as a student, you start. You put your table, then you do your you do the same thing we did. Because here in your question for chapter 5 that I'll give you, you see, I'm going to ask you convert decimal to binary. Then yourself, you start your table. You start 128. Then you put your value in your question. So this one is the combination of what? And after that, you identify and you put your answer. So these are 2 examples. And if you know them, then this example number 1. Oh, sorry. Example number 1 is here. This is example number 2. I put it down here. So it's the same thing. This is how it works. You'll get used to, at the beginning, it's strange, it seems confused. No, it's not. But because it's new, that's all. So we did manage how to convert decimal to binary. To do that, your table first, you put the number, you check it's the combination of what and what you took, you put one under. If you didn't take anything, you leave it 0 and you put the value here. Now, let us do the opposite. When you have binary, how are you going to convert in decimal? It's very easy. I'm going to show you here. Why we do that? Because at a later stage, we're going to, you see, we're going to convert binary to decimal. And when we're going to do subnetting, we're going to use binary, we need to convert to decimal. If you have this binary, what is the value in decimal? See? So this one, for example, this is the value in decimal. That's why we do that. So now convert binary 11110011 to decimal. Very easy. You take your table, you put your table here, always starting with 128 divided by 2, 64 divided by 2 divided by 2 until you reach 1. So this is the question, convert binary to decimal. So this binary, it's here. So then you copy it, you put it here, you put equal. Now you see this binary, when it's here, you must put it in this table. So you see, you can start from right to left. It's always starting good to start from right to left because the very first one is for this side. So I'm going to add for you the same order. There is one here. Then there is another one here. I put it here. The third one is 1. So the third one, the fourth one is here. After that, I have 0 and 0, 0 and 0. Then I have 1. So if you're using Microsoft Word, it's easier. You start from right to left. Because I'm using Notepad, that's why I'm starting there. But anyway, you see this same number, 1100 is here. 1100. You see 1100. And you continue 4 ones. 4 ones. Then you come here. So I have 1 under. So 1 times 28, 128 is, I took 128 plus, there is 1 here. 1 times 64, it means I took 64. 64. There is 1 under here, it means I took 32. Plus 32. There is another 1 here, it means I took 16. But here I have 0, so it means I didn't take 8. 0 times 8 is 0. I didn't take. So I leave it. I have 0 here. I didn't take 4. I leave it. I have 1 here. It means I took 2 plus 2. Then I have 1 under 1 here. It means I took number 1 plus 1. Then you see equal. You take your calculator and you clear everything. You do 128 plus 64 plus 32 plus to check the value. So 128 plus 64 plus 32 plus 16 plus 2 plus 1. What? 2, 4, 3. 2, 4, 3. Now your answer is the value of binary is 243 in decimal. So take your time, 2 minutes to double check, and we continue.
Sir, can I please ask a question? Sir,
Yes, ask your question.
so when I'm seeing how you're doing it, I feel like binary. You're sorry for the kids,
Mm-hmm.
they're making noise. I feel like binary is more easier than
Mm-hmm.
what is this one? The first, the value. Why is it like that? Because this one, okay, before even you did it, I did it already. I knew already the answer before even you did it. But then, why is
Mm-hmm.
it like that? Why is it like that? Why is this one
Yeah,
more?
no, that's the way it is. If I ask you why in grade 1 they told you 2 plus 2 is 4, it comes from where it's the way it is. It's the way it has been designed. Uh, when you have our human being thinking of uh, decimal number becomes 0, 1, 10, 11, 200, 1,000,000, we understand. But machines, we don't understand. The PCs, we don't have that. We understand either 0 or 1. So how to find a trick to convert all these numbers in binary with 0 and 1, it's what we are doing. And after that, we'll do the last one that's very easier. Yeah, so this is how it is. So to convert decimal to binary, always do your table. So decimal, that number, you need to find this number is equal to what? It's a combination of what in this one. You do it bigger than what? You start from there, 64. Then the result is bigger than what? The result until you find. When you finish, double check that this value is the same. And you put it. Yeah, the first one looks a bit difficult, but the second one is a bit. Yeah, it will it is, my sister, not life. But you'll get used to it, not difficult. We'll do that many times until you. Any other questions?
Hello, Mr. Mike.
Yes,
Mr.
your
Mike,
name and your question.
I'm Dean Sambo. Simple
Yes.
question that I want to ask. I think I did not catch that as the children up and down here. I see how you work out from binary to decimal. I see the 28 plus 64 plus 32 plus 16 plus 2 plus 1. But my question is this, if you look at on top there, where is 28, 64, 32, 16, 8, 4, 2, 1. But if you look under it, those answer 128, I understand, 64, I understand, until to the point of 2 and 1. Why it's only plus 1 and not plus another 1?
Okay. So everything start with this
Okay.
question, this binary. As I say, always you start from right to left,
Okay.
and you put it in your table. So you have 1, 1. You put your 1 here, 1.
Yeah.
After that, you have 0, 0.
Yeah.
You put 0 under 4, 0 under 8. Then you have 4 ones.
Mm-hmm.
1, 1, 1, 1.
Mm-hmm.
When you put it nicely like that, now you tap equal. Now you check anything you have 1 under, it means you took it. It's like
Yeah.
multiplication. 1
Yeah.
times 128, 128. 1 times 6. I took this, but here you have 0 under 8. It
Yeah.
means I didn't take 8. 8 will not show up here.
Okay.
Here I have 0 under 4. It means 4 is not taken. I will not see 4 anywhere here.
Okay.
Yeah, but here I took 1. 1 is under 2. It means I took 2. 1 is under 1. Then it means I took 1.
Oh, thank you, sir. Now I understand.
Yeah.
Thank you,
Then
sir.
you take your calculator, you clear everything in your calculator, you do summing.
Oh, thank you, sir.
You're welcome. Any other questions?
Yes, sir. Understand, Fabian, that's my name again.
Yeah.
I can't
Yeah,
remember.
Fabian.
Understand how you work it out, but my question is on the table that you put for us. By omitting 0, since you did not take 8 and 4, don't you think that you disturb the table the way it should be, or it's not gonna complicate in the machines, like, because this is a standard table that we have: 128, 64, 30, 32, 16, 8, 4, 2, 1. That's a normal one. But now when you work it out here from binary to decimal, we get another table here that is 128, 64, and so on.
No. I guess I hear you. No, this one is not a table. You see, this one is from this one, what numbers I took, you see. So this one is not a table. So for example, check this again. Convert binary so that you can understand that. Binary 00110011. Even I can even say 0 again here, 1. So in fact, let me solve this one, for example. I'm going to catch you in decimal. I'm going to show you. So when you have this one, convert this binary in decimal, what do? You copy it, you put it down here. You put equal. Normally it should be 8. That way, 8 numbers: 1, 2, 3, 4, 5, 6, 7, 8. But here I have only 6. 1, 2, 3, 4, 5, 6. It means it's the same number, but in front here should be 0, 0 because I didn't take it. So sometimes if I have zeros in front, I can remove and keep this one. Always start from right to left. You see. So this number is equal to the same. Now we take this one, you put it down here. This is the correct number. Correct number. You take your table. You see our table on top. I remove everything. So I have what? 0, 0, 1, 1. I put 0 here. I have 0 here. Then I have, let's always start right to left. But here I'm starting left to right because I don't have Microsoft Word. It's changing my stuff. 1, 1. Then you have 0. You have 0. You have 0. And you have 1. So you see 1, you always start right to left. 0, 1, I have 1 here, and 0, 0, 3 zeros. So I have my 1 here, my 3 zeros. It's fine. Then I have 1, 1, and 0, 0. See, 1, 1, 0, 0. So this is how it is. Now, I need to put, so I have 0 under 28. It's like 0 times 28 is 0. So I have 0 under 128. It means I didn't take 128. I'm not going to put it here. I have 0 under 64. It means I didn't take it. The value is 0. I have 1 under 32. It means I took it. 1 times 32 is 32. 32 plus I have 1 under 16, or 1 times 16 is 16. I took 16 plus. I have 0 under 8. It means I didn't take it. 0 times 8 is 0. 0 times 4 is 0. 0 times 0 is 2 is 0. I didn't take them. But 1, I have 1 under 1. It means I took 1. Then you take your calculator, you clear everything. 32 plus 16 plus 1. 32 plus 16 plus 1 equal 49. You see? So what we have here, it's not a table. It's the value of what you took here. I took this, and I took this. My table is this one. But here is not, that's why I say equal. It's not, this one is not a table. So if you have a binary like that, for us human beings, we understand 49. But the machine understand 49 in its own language. Like how I want to translate French to English. It's the same meaning, but it's different. So for us human beings, we understand 49, but the machine, we don't understand 49. We understand this. It's the same value. Okay, so the last one is, you have a question? Any questions?
Yes, sir. Please, before you go to the last one, can you please maybe try to make a table for me? Like you say 120. Is it always 128 to 1, or is the different one?
Now, this is your table, 128. This is your table here.
Yeah.
128, 54, 32, 16, 8, 4, 2, 1. Done. This is your table here.
So my
Just
question
because
is,
yes,
yeah. Oh, my
yes, a
question
question.
is, I want to like know how to make this table. My problem, I'm already seeing it's only going to be between decimal there. How, if I want to make my own, how can I do it? The table especially.
Word, and just because I don't have the license for that Microsoft Word, I cannot. Let me see if you're going to allow me. Okay, if you want me to pay, close Word. I don't know how to in this. Let me check in this document. So if I put it here, no. Let me check. Can I insert? Can I insert table? Page break, image, media, shape, text. No. Table. I have table here. Table of content. What's that? Column. Eight. Now what again? This software of mine, I don't even understand. Oh, no. Just because I don't have. So if you have, I'm going to buy the license so that way. So your table is what? Let me open chapter 5 for you, so that maybe you could understand. Yeah, if you have questions, just unmute yourself, tell us your name, and ask your question. I'm going to find. I'm going to show you now. System chapter 5. Outlook. Now this one is not F5. What is it? F5. Slide is F5 slideshow. Yeah. So in chapter 5, if you go to nervous system, let me charge my. That's why I say normally in IT, this is not difficult, but because it's new. If you know this one, it's finished, you know everything. But we do it many times, so numbers. I'll show you the table. I'll show you what table is. Yeah, so if you go to chapter 5, it's what we are trying to make it very simple for you. So if you go in NetAcad, it will be more complicated. I know my people. So you have a video where they explain. Yeah, I know my. We're going to explain the position, the powers, and base 2 and what. You see, we're going to get complicated again. Position. So I didn't want to complicate. But that 128, 64, 32, it comes from here, as I see, because of the position and you see. So if you have a table, I'm going to show you something more easier. You see, this is your table. You start. This is your table. You start like that. Then under it, you put the value of here. What is erase? So you see here you have your table. You start with 128, 64. And from there, if they ask you to convert this binary, it's what we did. You see, I took 128, and you see the value on, sorry, this, yeah. The value of this binary is 192. This binary, this is the value. 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 So you see, this binary, there is 1 under 128, you keep it. There is, or you can say 1 times 128. There is 1 under 64, I took it. But there is 0 under 32. 0 times, I didn't take. You can say plus 0 if you want to. You see. And when you take this one plus this one, when these two, because anything else is 0, 0, 0, 0, this will value. So if you go in NetAcad, it's a bit confusing in NetAcad, but I'm trying to make it. So we're talking about your table. Always start with 128, 64, 32.
Yes, sir. So I now understand. You see, because you said that no, you always come up with your own table. So then,
No. Your own table means you start 128, 64. Yeah. So it comes from there.
okay. Oh.
We are doing that because when you have an IP address, this is an IP address. For us human beings, we understand this. Like your Vodacom number 082 33. For us human beings, we understand that IP. You see, but for a machine, the PC, they don't understand that. You see that 192, they understand this binary for 192. That's 168. They understand that binary. For us 11, the PC understand that binary. For us number 10, we see the PC. So you see on top here, so 192.168.11.10 for us human beings, we understand. But we need to convert all of them in binary. In binary for the PC to understand. Oh, so the PC, the PC needs to change. So our 9, let me clear everything. Our 9, this one, Oh, yeah, this one. For us, we understand 192. You see, the second one. So our 168 will be changed in binary. So each of them will be converted. Each of them will be converted in decimal, in binary. So 192 will be converted to this binary for the system to understand. This will be converted in this binary for the system to understand, and so forth. So as a network engineer, you should be able to convert decimal to binary and binary to decimal. If you go in AutoCAD, sometimes it's a bit confusing. Yes, you see, for example, this table there. See? Always do your table. This is a nice table. So, for example, decimal 168, this is the value in binary. It seems strange. We all been there. I know all my students for many years, for more than 10 years. The first time it's confusing, but after that, it's much easier. Let's do the last one. The last one is, yeah, so you see, for example, here, IP address for us human being, we understand 192, 168. But the PC, we need to convert in binary. The PC understands these numbers. So read here. The most difficult part in Cisco is this part. If you understand, it's easier, then it's finished. Anything else is easy. Okay, so we know this. Now hexadecimal is the most easy. So this is hexadecimal here. And it's used by what? By MAC addresses. So it starts from 0. When it reaches 9, there is no 10, it starts with A, B, C, D, E. So 0 in hexadecimal, you must convert in binary first. Then from binary, you convert to decimal. That's why you see binary and decimal are very important. If you take F in hexadecimal, this is the value first in binary. Then you convert that binary to decimal. So check this one for 2 minutes. And the next 10 minutes, we are done for today. Next time we continue. Yeah, so that's the thing, guys, but it's not difficult. So if you have two numbers, if it tell you convert hexadecimal AB in binary or decimal, it's very easy. I'm going to show you. So this table, you should be able to know it. Decimal, it's easy from 0, 1, 2, 3, 4, 5, 6, 10, 11, 15. It's fine. It's okay. This one is fine. Hexadecimal 0, 1, 2, 3, 4, from 9, A, B, C, D, E, F. This one also I can see it's fine. The most difficult, how are you going to memorize the binary? It's very simple. So if you go to right to left, and you have 0, you see 0, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, and 0, 1. After that, it will be 2 zeros, 2, 1, 2 zeros, 2, 1, 2 zeros, 2, 1, 2 zeros, 2, 1. After that, 4 zeros, 4 ones, 4 zeros, 4 ones. Then 8 zeros and 8 ones. See, then you have all your value. So it's something you need to work on it during the weekend. Any questions? So this is an example I'm going to show you. Yes.
On the hexadecimal, so you want to tell us this is the table of hexadecimal?
Yes, this table you should know.
Okay.
Yeah. So decimal, it's easy. You come from 0 to 15, it's okay. Hexadecimal is also okay. 0, 1 from 9. It's an F. Now the big deal is binary. So from right to left, the first column, this first column is 0, 1, 0, 1, 0, 1, 0, 0, 1. Second column, 2, 2, 1, 2, 2, 1. After that, 4 2s, 4 1, 4 2s, 4 1s, 4 zeros, 4 1s, 4 zeros, 4 1 until the last. Then the last one, 8 zeros, 8 1s. You see. So the first is 1 0 1 1 1 1 0 0 1 0 1 double 0 double 1 double 0 double 1 until you reach 4 zeros 4 ones 4 zeros 4 ones. Then here 8 zeros 8 ones. Then you are done. You'll get used to. No worries. We all went through all this stuff, but
so we have to memorize this table. Or
no, not memorize, but you should know how to do it. That's all. But we don't need to memorize. No need to memorize. So now I'm going to give you a very simple example of conversion hexadecimal. So if you can see convert hexadecimal AB in binary, it's very simple. In your conversion table, B, this is the value of B. A, this is the value of A, you see. And that's so. It means hexadecimal AB, this is the value in binary. You take one block, you put the value according to the table. You take the other block, you put the value according to the table. Listen. Now, if they ask you convert hexadecimal AB in decimal, it's where the problem starts. Convert hexadecimal to decimal, you must go via the binary. You go via the binary, and from there you continue in decimal. So here, convert hexadecimal in the hexa, that's why I prefer hexa into decimal. You must go via the binary. So this value is the value in binary. Then this one, you take it, your table. Sharon, this is your table now. You start 128. I'm going to call it Sharon table. You put with Sharon table. This is Sharon table, 16, 8, 4, 2, and 1. This is your table. You start with 128 divided by 2, 64 divided by 2 until you finish with 1. This is your table. Now, this number, you need to put it in your table here. So we're going to do. So I have 1, I have 0, I have 1, I have 0, I have 1, I have 0, I have 1, and I have 1. So you see, I have 1101, it's here, 1101, and I have 0101, 010. So I did put in my table. Now I check the value. So I have 1 under here, it means I took 128. I have 1 here, it means I took 32. I have 1 under 8, I took 8. I have 1 under 2, I took 2. And I have 1 under 1, it means I took 1. Then I take my calculator to check the value. I clear everything. So this one, 128 plus, I take my calculator, 128 plus 32 plus 8 plus 2 plus 1 is equal 171. So you see, convert hexadecimal AD in decimal. This is the answer, 171. You must always go via the binary, and from binary you go to a decimal. Okay. Then if you have decimal and we want you to go to hexa, you do the same thing. This decimal, you convert first in binary, and from binary, you divide by 2. You see, the first block, the first 4, the other 4, and you check in your table, the first 4 is equal to what in hexadecimal, and the other 4 is equal to what in hexadecimal. So let us stop here for today. If you want, you can go through chapter 5 if you want to. It's a bit confusing. I'm telling you, if you go there, but if you want to, but and you have a video converting hexadecimal to all this stuff. You can go to chapter 5, and yeah, we didn't have time to do what I wanted to tell you because of these conversions. Yeah, but next time we'll continue. The most important is subnetting, what we should do. This is the table again from Sharon table. See. But at least, yeah, we'll do this one next time. So for during the weekend, focus more. I'm going to send you some questions like this one. I'll ask you to send me your answer. So you put your answer in the class WhatsApp group. Don't send to me. If not, I'm going to get to it. But please make sure it's clean and neat, and don't. In fact, don't post anything. Just keep it. And the day we meet, and you tell me your. Yeah. So this is a small homework for you. So after that, no worries. You'll get 2 weeks break for you to relax a bit. While I'll be busy during these 2 weeks to catch up with IT essentials, then we all merge with 2 groups. So yeah, let us keep it simple. And any other questions? Okay, if no questions, thank you very much for tonight. Try to do some revision during the weekend, and Tuesday we continue. And when we meet on Saturday, the next Saturday, not this one, first Saturday of March, the 7th, we'll do a global revision about anything. the conversions, how to configure a switch. And on that day, I'll also show you how to configure a router. It's very simple, but it's good to know how to do with packet tracer and also with the physical equipment. Next time, you'll need a console cable to go to your PC. Now you need to log on the console cable of your router. And from there, we continue. So Saturday will be very, very important. Next Saturday, the first Saturday of March. Please don't miss it. It's very, very important. Yeah, after that, we'll have time to study again. And we won't have any in-person meeting for a while. Then we can resume later. Thank you very much, guys. I'll post the recording tomorrow for those who want to watch again.